My name is Mustafa Polat. I'm one of the directors at Alpeating Limited. I'm director of operations actually. I'm a building services engineer by trade and worked as a heating engineer slash heat pump and air conditioning engineer for in the past 20 years or so. And we come here today to have a chat with Tony and with my co-director Erkan about an air source heat pump installation with some discrepancies. We would like to discuss and see what we can do to put it right, to make it the most efficient. We have taken some pictures and videos of the existing installation. You will see that quite a few things wrong. We are here to discuss with Tony what we can do to put this right, to basically redo the installation by salvaging some of the pipework and the unvented cylinder. The original problem was once we went through the handover pack has been handed by the original installers, have mentioned an unvented cylinder with a pressurized system fed by mains, unvented G3 kit, a buffer tank have been installed as it should have been, but unfortunately what we see on the installation is not quite matching what's on the handover pack. So the system was fed by the original hot water tank upstairs in the loft, which was very dirty without a lid, and we had to clear a lot of large pieces of fiberglass insulation from this tank, and as it was gravity fed, it's probably due to low mains water pressure. We will check that in a minute as well. And yes, now we will discuss with Tony. We'll ask him a couple of questions about what went wrong. We have also checked the efficiency of the system. The house insulation is quite good. The heat loss levels are relatively quite low, and Tony has solar panels, solar PV panels, and a battery, so which made him hope that his system would be really efficient and his bills would be really low, but that hasn't been the case. We will go through and check, find out the reasons for this. Can you tell us what happened during the installation? Have they explained to you what they were doing and how would they make sure the system would be efficient?
To my recollection, no. I mean, I'm not that way inclined, engineering wise, so I trusted them to do what they needed to do to get the job done, basically.
After our conversation, we have advised you to call MCS and find out about this company. What did MCS say?
We looked into the insurance that you get. You get a 2-year insurance since the date of completion for if the company goes out of business. So when I spoke to the MCS people, they said no, they're still trading, so that won't be in effect. You need to go back to them to get the job corrected. They actually looked into it and they said they're not registered with us anymore.
They are not MCS registered installers anymore.
No.
And you have an insurance in place from MCS. It's mandatory by MCS installers. If something happens with the installing company, there's an insurance in place to protect your rights. But in this case, the insurance company told you that the company is not being liquidated. They are still active, so they can't help you.
Exactly, yes.
So their policy only helps you in the case that when the company is bankrupted or closed down, or
That's correct. Yeah.
yeah. So the only option we had was to go back to MCS and see if we could reapply for the grant, because the original grant hasn't been used. It seems like the installers, the installing company who did the job, they've been struck off the MCS accreditation, and they have taken the money they paid to them on behalf of you. It seems like they have taken that money back from them.
That is correct. The government have actually reclaimed that money due to there was an error in the administration by the company. So when I rung up the government about the grant, they said yes, you will be eligible to apply again.
Yes, and I remember they said you would need a new EPC certificate explaining the situation.
That's right. Yes.
Yes,
Yeah, you need an EPC, which we got, and that come out pretty good.
Yeah, and yes, you did get a new EPC, and now we are almost ready to get on with the work.
Yeah, the grant's been approved, the voucher's been issued,
Yes.
and we're ready to go, hopefully.
Yes. Well, thanks to Tony, and we have Erkan here with us as well today. This is my co-director at Alp Heating Limited. He's going to explain us about the passive controlling system we recently started using to ensure efficient operation of air source heat pumps and similar systems.
My name is Erkan. I'm one of the co-directors at ALP Heating Limited. I have been working on heat pumps more than 15 years. My background is more refrigeration and hydronic engineering. I came to visit the property after seeing our engineer report. When I looked at it, I was a bit shocked, but when I went through the system, it was worse than the engineer report. With any heat pump installation, as well as the heat pump being so important, but also the design and controlling the heat pump is very, very important. So both of them being not right at the same time, the heat pump efficiency will die. So that's why we have a company we are coordinating with at the moment. I will introduce the passive smart thermostat that will integrate the Tony's electricity tariffs at the same time. So we'll bring the heat pump on for a hot water or Legionella whenever the Tony's electrics are cheaper. So and also the passive says for any of the heat pump who use a passive thermostat, it will reduce the electricity bill by 17%, which I'm sure this will help the Tony's the bill as well. At the same time, when we install the aux unit, because we are a PCDP and a sub-listed product, and which is very high, that will bring the B to A on the EPC report, which is we are confident we already checked that. I'm sure once we install the aux unit with a 10-year warranty, this will resolve the issue that the current heat pump be the 40% blocked in the heat exchanger. So we will make sure we clean the system, flush the system before we do the installation.
Here we have a 150 litre UK cylinder, unvented cylinder, but it's been installed as a vented cylinder because the original feed tank in the loft has been kept. We went up and looked at it with a couple of pictures of we can add later, but we'll check the mains pressure. Providing the mains pressure is okay, we will refit the G3 kit and use it as an unvented cylinder. because at the moment the water coming through the taps is extremely dirty and contaminated due to that the old feed tank is being used as it was. It's already, the tank is already old, and the water inside is already contaminated a lot. But during the installation, I believe some because there's no lid or cover on it, some large bits of insulation fell in it. So we carried some 2 buckets of bits of insulations out of the tank, but the tank is still dirty. So hopefully we will turn this into a much cleaner, unvented system as it was originally designed and meant to be. This is the mains cold pressure coming in. It's about 12 litre a minute, and this is the pressure of our hot water coming through the tank, coming from this tank upstairs. So we will, once we have completed, we'll make sure the pressure of the cold water mains coming in and hot water is the same. So existing unit here is a Mitsubishi Ecodan R32 air source heat pump. It's a good unit. It would be a lie if I said it's a bad unit, but the water in the system, central heating system, is really dirty because the existing heating pipes have been used and seems like it hasn't been flushed, and the filter inside the Y filter have been removed, as we found during the installation. And we also measured that the flow rate coming back from the evaporator, we also call it a plate heat exchanger, is very low. So it's a suspected evaporator blockage, which will avoid the warranty from Mitsubishi as well. So even if they come out for warranty work, they will reject, they'll deny the warranty, they will void it because of the dirty water in the central heating system. So we will replace this with a AUX R290 unit, which will give a lot better efficiency. I mean, not because this one is bad and the other one is a better unit. Previous technology, R32 refrigerant gas, but the new one will be R290. And as you can see, the pipe insulation is quite poor. The primary pipes are 22 mil. We will see better once we do the calculations. We'll do pipe sizing as well. We'll see whether we need to increase the size of the pipes or not, but we will definitely improve the insulation, and we will put the pipes inside the pipe trunking.
One of the big issue we found also with this heat pump is been rattling, and obviously no need to be an engineer to discover why it's been rattling so bad. It is not even level, it's down to the poor installation. When the heat pump isn't level, first it will damage the fan motor, and the compressor will make a bit louder noise and it will rattle. This is the case, so it's been happening here. So what we will do when we do new installation with AUX R290 heat pump, we'll make sure the heat pump is level 100%, because that is one of the most important the point on the installation. And we have a special design filter. It comes with the AUX heat pump, which will increase the warranty up to 10 years.
Back to the office to pick up where we left from, the Tony's design. And I just wanted Erkan to explain a bit more about the passive smart thermostat system. What was the latest integration with it? Yeah, Erkan, if you can please tell us more about how we will integrate that to Tony's house and system.
So passive control system, they invented a device which is a heat pump optimization. Basically, the device made in UK, more importantly made for UK consumers, So all the feedback we were getting from a heat pump controllers, it was difficult to understand, difficult to use, because all the international language has been translated into English, and also the engineering language wasn't helping to our consumers. So what the Passive did, they did old, I would say, traditional programmer, very similar to one we use currently in our homes. And the customer can do 1 hour push button for a heating, 1 hour push button for a hot water. So they will have a physical control system, as well as a wireless room thermostat, which is in the box here. It looks like a very traditional room thermostat when it's connected to the heating system. But what it will do, instead of turning the heat pump compressor on and off, it will reduce the flow temperature up and down when it needs it to. So it will squeeze every part of the efficiency from the system and apply into our heat pump. Also, this will connect to the customer's smart electric tariffs. Whenever the heating electric is cheaper, so it will heat the home, it will heat the hot water, it will adjust accordingly the consumer electric tariffs and the prices. Also, it will understand whether the customer has a solar panel or not, so it will work accordingly with the sun and the production of the generation of electricity at the time of the day. Yeah, that's about it.
So it will help the installers as well, then, as well as helping the homeowners for
definitely
ease
so
of use.
it's so easy to use. They have an internal wiring center, which is the diverter valve, and the pump can be wired into the box, which will make the installer much easier, and there is no need to bring additional diverter valve or a pump cable all the way into the house from the heat pump. The only connection they will need from our wire controller into this controlling system as a Modbus cable, which we will provide.
So
anyway.
instead of having to take 5 loads of cable from heat pump into the house for your 3-port valve, for your pump, zone valve, any additional pumps, instead of taking all those cables from heat pump to the house, all you have to do then take Modbus cable, your communication cable, from heat pump to Passive, and the rest of the wires will be distributed from here.
That's right.
So that's a big help to.
So this can go where the airing cupboard, where the diverter valve and additional pump, if there is one, it can wire into the system, and then the connection will be made between the heat pump and the wireless thermostat, so the consumer can actually see the temperature of the room and set it up accordingly.
Yeah, because currently when we install, we struggle to explain the homeowners, because a lot of them don't understand these complicated digital stuff, and they keep having to call us, and sometimes we have to go back because they don't understand the settings. So this will save us a lot of time and hassle, because it's much simpler.
That's right, and also what the Passive is saying, there is no need to weather compensation needs to be set it on the actual heat pump, because this will do itself. So plug and play, I should say, really, and it will learn the customer's electric tariff, how they use their heating system, what temperature they usually keep their heat pump at, and all those information with the technology of AI, it will integrate into the Passive system, and it will work accordingly.
Let's try this in Tony's house, and Tony is a good person for this as well, because he likes his efficiency in his house, going green. He's quite keen.
That's right.
He's got all the setup, and he likes to monitor how much electricity is using for how much heat is being used in his house. So I think it will be good to try this in Tony's house. Let's try and see. Okay, we came back to Tony's house today after about 3 weeks after completion of the installation. We usually visit customers after a couple of weeks, check to make sure everything is okay, all the readings are okay, the parameters are okay, the unit and the system is working efficiently. And I'll let Alp, one of our young engineers, so he was kind of responsible with this install. So he'll tell us about how they did it.
So this is our 4 kilowatt heat pump with the black trunking. We obviously installed 28mm pipes, flow and return, going up into the airing cupboard, of course, yeah. And we have the same trunking used here, which our air conditioning team was also here at the same time, installing an air conditioning unit. Buffer tank and expansion vessel we had to put into the loft as there was no space in the airing cupboard. But yeah, it's turned out absolutely perfectly. The flow rate of this is 35 degrees with a delta T of 5. So this is our air conditioning unit that was fit in the same day while we were installing our heat pump. As you can see, they've used the same trunking. Their one goes up to, I think, the 2nd floor where the air conditioning units are. And you can see our trunking here going up to the airing cupboard.
Okay, we are back here to see Tony again. Hi Tony.
Hello.
Good afternoon.
Afternoon.
So we usually, like I told you before, we visit customers after a couple of weeks of every install to see everything is working okay.
Yeah.
To make sure we are reaching our targets with flow temperatures and delta T's and efficiencies.
Yep.
So we came here today, obviously we took a video at the beginning.
You're right.
So we thought we may as well take another video at the end. And this is the app. Maybe you can have a look at it. Me and Tony, we had a few phone conversations, so Tony's quite comfortable with it. The electricity usages, the efficiencies, monthly, yearly, daily. So we are a little bit better than our anticipated parameters. So we are really happy with everything. Air conditioning units are working good as well, as Tony said, but the weather is not too hot yet, so we'll know.
No, haven't needed to use it, thankfully.
So we'll know that in the next couple of months rather. We are in April, 1st of April today.
We are indeed, yes.
Yeah, give it another couple of months. We'll have some feedback about the air conditioning units.
Yeah, so we are now upstairs. This is obviously where the airing cupboard is. This is where the trunking is being pulled. Obviously you can see the air conditioning unit as well that I was talking about for the other trunking that was used. If you just come around here, I can show you our controller for the heat pump. So this here is our control unit where we can see all aspects of the heat pump. We can see here is heating and here is hot water. We can see here there is a little mark next to the heating. This is weather compensation mode. So basically what weather compensation mode is, the heat pump works on how hot or how cold it is outside. So let's say it's boiling outside, it's a very hot day, then the heat pump will work accordingly. It won't work with as much power, but let's say it's a freezing day outside, then the heat pump has to work with more power to reach this level that you want. On our controller you can obviously see there are loads of other options here. If I just go here just to quickly show you, this customer has put the mode on custom. He's chose how he wants his heat pump to work accordingly for his benefit. And we can go down here to unit status. This is really the sweet bit, you know. This is where you can see, you can do all your fault finding, what's really going on in the heat pump. We can see here that the compressor isn't working. There is a refrigerant gas of 692.4, and there is a cubic meter of flow rate of 2.1, which is absolutely amazing. So on this side we can see the refrigeration circuit, obviously the blue side, and on the right side we can see the heating circuit where you can see the temperature differences, your delta T's. So by looking at your delta T's you can obviously work out if there's any blockages or any issues with the flow rate.